Okay, welcome to this video, and in today's video we want to look at strings in Rust. And basically we're going to be looking at dynamic strings and static strings. But let's look at how to manipulate static strings. We know that if we want to declare a string in Rust, we can say let that string A equal to something like hello world, but I don't want hello right now. And maybe I want to print out that very string, which is A, and let me see what I'll be printing. So if we go to Rust, and we are getting an error here, and okay, this is a double colon. That's not what I expected. We do this again. Yes, at least that's what I wanted. And then main, and we see that hello is being written. So let's do something else here. What if we want to mutate this string A? Definitely you're going to get a problem there. So, but let's go on either. So we declare the same variable A, and we're saying that we want to change A into LO. And then if we print again, okay, with the use of Copilot there, and try to do the same thing again, you expect a problem there. Yes, voila. Why? Because of mutation. So in Rust, we are trying to mutate this variable of a string, and we are not declaring it as mutate. And by default, all variables in Rust are immutable. You cannot change them. So once we put the mute keyword there, we expect things to be fine there. Okay. And once we call the build file main, I'm not using cargo here because this is a small sort of like a program, so I really didn't want to use cargo. Now you see that you're printing LO separately and hell separately, and if you want to see some manipulation of some sort of facade that you are mutating, you use the print keyword, and you will see how this changes. If you put that, you call main, you see it looks like you have, but it's because the print doesn't like create a new line. So, but you're definitely printing different variable. This thing has been completely mutated into this, and there is no like appending to that. And why is this the situation in Rust? This is the situation because by default in Rust, every string literal is declared as an str. When I talk about the str, I'm talking about the string reference str, and that doesn't comment as the reference string, the reference str. So every string that we declare is by default an str string, which is immutable, which is declared as unmodifiable array of bytes, and that array is like a UTF-8 string. So each time the compiler passes a string literal or a literal string, it stores it in a static program area, and the characters of that string so are stored in a static program area, and such area is of the str type or the str sort of variable here we are talking about. So the compiler uses that uses a reference to such area, and the value of such a literal string or such literal expression is of the type this one. That is something important that you need to know. Now, if we dig deeper into variables, because it looks like we cannot it's not possible to overwrite the characters or to add onto this, but you have completed creating a new variable in memory, and these are called static strings in Rust, and by default strings in Rust will be static. But how do you create dynamic strings? And that's something that we want to look at now. If we go further and look at this, if we declare a variable let A I won't call it A. Let X. That will confuse maybe. Let X equal to a reference str string equaling to maybe nothing. So it's an empty string. And we let Y a different string str equaling to maybe integers or numbers 1, 2, 3 up to 0, 9, 9. Because we already have 0. 1, 0 up to 9. Those are 10 literally. So let maybe Z also equal to a reference str, and this should equal to maybe something like A, B, C, D, E. And yeah. So once we are seeing now that we are declaring these strings as directly as string literals. And the point that we want to make is about the storage and the difference of these strings in memory. Mainly, something that I want to demonstrate here is about memory. If I can use some of the Rust packages, use std. If you don't know about these packages, go to the crates.io. This is memory. So we want to use certain utility packages within the standard template library, within the standard library of Rust. So that memory means, this asterisk means we are like almost inheriting everything in there. But we are not going to be doing that definitely. So if we want to see the sizes of these, good GitHub Copilot is completing this. I want to print out X, Y, and Z, and maybe, okay, I can print out that, and then print line, exclamation, okay, and we want to print. I'll use like maybe this is okay. I'll say X, and I'll say a comma, Y, okay, a comma, Z, and I don't want this. I want to use the size of val method from the memory or from the standard library, and this will be like size, something I can't type here, size of, okay, GitHub is, Copilot is finishing it, size of X, yes, that's what I want, and size of Z. Now, these sizes, we are going to see what the size of val is doing literally. Then I might need also print ln, and I really don't have time to, I'll put the other the curly braces still, and now I want to say size of val, and what I want to print out from there is I could maybe I should, okay, that's okay. The difference of X, just hold on, this might be confusing. Size, I'm going to explain what is going on here, and size, reference of val, and size of val, reference of Z, size of val, reference of Y, size of val, reference of X. So we want to see what do we expect? Definitely, you are going to expect an empty string, this and that for this print statement. For this print statement, we should expect what? What should we expect there? We should expect the length of the string. And here, we should expect the size of the reference. The size of the reference. Okay. Actually, the size of the str. It should be the reference string, so to say. And this has a funny name in Rust, which you call the fat pointer. And probably, if time allows, we're going to see what that fat pointer means. So let's first do that and print and see. If we run and then call the main, we can see, as we expected, x, y, z. X size is 0 and y is 10 and z is 5. That's basically is length of the string. And we can also achieve this by calling the length function on that. If we do print and call the length, yes. That's like calling the length of the function. Sorry about that. So this one is and this are doing the same thing. But now we are seeing that on the second size of val of the reference string, we are basically printing out the size of the string reference or of the reference string, and which is on a 64-bit machine. It occupies a 16-bit. If it was a 32-bit machine, it would be 8 bytes. So these are 16 bytes, and because this is a 64-bit machine. Now, that is to basically show you that the string reference in memory is called a fat pointer. Why? Because it's sort of like it stores a reference to the pointer, and that pointer points to the first character of the string. But also, once it stores the pointer, it also stores the pointer. It stores the length of the string itself. So it stores like two things. That's why you will find words like a two-word machine. Now, these are basically the static strings. Now, what if we want to talk about dynamic strings? Well, Copilot, I don't know why it gets those things. That the reference string is immutable, so we cannot change the content of the string. That's true, basically. It's what we've said. But we want to talk about dynamic strings for now. And for you to have dynamic strings, this is one of the ways that you can have dynamic strings. You're going to declare a variable, let mute of maybe r of a string type, and you might, this is one of the ways, but I don't want to use this. So I'll use, maybe it is xy dot, we use the dot to string method. Note that the to string, the s there is lowercase. Now, with this, you can manipulate this string. It can grow, it can expand, it can reduce by saying r.remove maybe the first character, and r.push. I can push maybe, or I can insert, r.insert, they all work. And with insert, I choose the position. And I can say at insert 0, insert maybe, I don't want to insert y, I want to insert h. Okay. Then we can say r.pop. We want to pop, of course, the first, because it is behaving like a deck. r.push. Yes, we can push rl. And then maybe we want to print. What do we have there? I don't need that. Brain break. So if we run again and call main, we can see that we have, we have completely moved from xy, and because we insert h at this position, but then we remove y, it goes away. We put h goes away. This is the HL that we are talking about. The avoid the confusion, I can put a print line there. Okay. Again. Okay. Yes. So this is what we have ended up with from this. And the reason why we talked about this will be clear in our subsequent videos, why we talk about the reference string. But mainly wanted to show that by default, all strings in Rust are of this type, and they are immutable. And even when you declare the mutable keyword, there are ways you cannot just overwrite the previous word within the same memory or within the same variable. And if you want to really manipulate strings by expanding them or shrinking them, this is how you go. There are other different ways close to this, but you will see that in the subsequent videos. So that's all I had for you in this video, and thank you guys for watching. Please feel free to leave a like, comment, subscribe, and see you guys in the next video.